Yeah, how are we, class? We are doing well. Now I wanted to give you a small riddle here before we discuss what we have come to discuss today. Today is our 6th topic, and that is Algebra 2. It's broad. See, it has so many things. Of course, algebra is a lot. We shall meet more algebra in senior 3 and 4. So, are you very attentive? Yesterday I met my 3 friends, and two are twin brothers, and one is alone. Then I wanted to take them to a concert, but there were 2 options for me, and I was looking for the cheapest option. Either I was to take one brother of theirs 2 times to a concert, or I was to take the twin brothers at the same time to the concert. Which option was cheap for me to do? Let me repeat. I have a family which contains 2 brothers, and all of them are my friends. In that family, 2 are twin brothers, 1 is not a twin. I wanted to take them to a concert and pay for their tickets, but there were 2 options. Either I will take twin brothers at the same time, at once, 2 of them, and we go to a concert, or I can take one brother, but I take him 2 times. We go and watch the first concert, then we go in for the second concert. Which one is cheap? To take one person 2 times, or to take the 2 people once? Which is cheap? Could you explain that?
I think to take the 2 people at once.
Yes, how would that be true? Now, assuming I'm buying tickets, which one is cheap? 2 people at once, or taking 1 person 2 times? And you explain that? Yes, Chirabo, you are set to say something. Which one is cheaper?
I think taking the twins at once.
At once. Could you explain why it's cheap?
Because if you're taking the twins at once, that person that is alone is you. So meaning you all have to go at the same time.
You're saying taking 2 people at once is cheaper. It is correct, but you will not finish. The explanation does not come out. You explain in terms of tickets now.
I think 2 people at once is cheaper because you're buying 1 ticket. And if you're buying for the same person 2 tickets, it means it's very expensive. That's what I mean.
No, each person in the ticket is the same amount of money.
But 2 people at once.
Yes, but each individual, each one whose ticket costs the same price as the other one whose ticket. I was so perturbed yesterday. I don't know which choice was better, to also save something for my pocket. But incidentally, I had to make a decision, and it was more cheaper.
Teacher, I beg the pardon on the question.
The question says, I have a family of 3 people. 2 are twins, 1 is an isolated brother, but there were 2 options for me in buying their tickets at the concert. Was it cheaper to go with the 2 people at once and buy their tickets and we go for a concert, or I take 1 person 2 times?
Teacher,
I think taking two people at the same time. Because if you're three, meaning you're part of the family and you're going to make the third person.
Okay, Mira, you say final answer, then we go to our topic.
I think two people. Because when I take two people at once, might watch and then it gets finished. But then when I take one by one, maybe after the first concert, the second one, the money might add, and again I have to pay. That's why I think.
Okay, thank you for your contribution, guys. But if you look at it in this way, if I take two people at once, how many tickets am I buying? 3. Not so?
Yes.
What if I take the same person 2 times? How many tickets do I buy? 4 tickets. So when I take 2 people at once, I buy 3 tickets. That will be cheaper than taking the same person twice, because I will be paying myself and for him, so there will be 4 tickets. So learn how to save, not so? Okay, let us discuss our topic here broadly called Algebra 2. There is a lot in it. Algebra 2. And we are going to discuss a lot. Now, we said algebra is so broad because dealing with the letters is what we call algebra, dealing with letters in place of numbers. So the first subtopic will be expanding brackets. Expanding brackets. Then we shall have building formula. Building formula and making subject of the formula. Making subject of the formula. Yeah, then we shall have to discuss factorization. Factorization. Then solving quadratic equations, and that will be the whole session. Now we see that there is that third algebra. Now we shall have to this subtopic here will be divided again to have part of it discussed in senior 3. So we shall suspend one item on it to handle it ahead there. So let us go to expanding brackets here. I pray that you really be very, very attentive and understand, see, and understand. So expanding brackets. I hope you recall the concept of like terms in the first algebra, solving simple equations which are linear. You recall that? That's wonderful. So we can, since you recall the concept of like terms and also solving equations, let's just bump into this expanding brackets. So expanding brackets here. That one will take us to, okay, we can start with the just discuss, simplify the following. By expanding. Do you recall that small bit of expanding of senior 1?
Yes.
One item outside the brackets.
Yes.
To expand is to open the
Brackets.
brackets with each term, with the term outside affecting the terms inside. So who can remind us this? That will take us to 2 times x plus 2 times 6. That means it affects everything. So we get 2x plus 12. Not so?
Yes.
Yeah, that's wonderful. That's wonderful. Okay. Oh, that means you'll try out for me when we say negative 4 into x minus 4. How can we handle that?
Negative 4 times x plus
Times x plus
4 times
this negative times the negative, the positive. So that will be 4 times 4 and giving us 4x plus 16. Yeah. Okay, those are simple expansions, but we are going to expand a bracket with another bracket. Okay, that means expanding a product of terms in 2 brackets. So, but the concept is borrowed the same. The concept is the what? It's the same, that each term in the first, like if we had x into this, x minus 3, expand each of the following. So, are you attentive there? That see that during expansion, the terms in the first bracket must be multiplied. That means this first term will be multiplied into that bracket, even this will multiply that bracket. What does that mean? You'll hold the x first into the second bracket. Not so? Then you see this. This is what? Plus. Also 2 into the second. So this into this, this into that. But you maintain this sign. So, yeah, I hope you recall that concept. X times x. It is x squared. Not so?
Yes.
Minus x times 3.
3x.
3x plus
2x.
2x. Then this is a positive term affecting that. That's positive times the negative, that is negative. Then this gives us 6. So this and that are like terms. Negative 3 plus 2. Sure.
Negative x.
Negative x. Or simply 1x, which is x, not so? Then minus 6. That's right, that's right. Oh, there you are. From minus x into 6 minus x. Of course, I'm doing this and another one. Then I also pick on you to do for me. So we hold each value into that, then this into that. So what shall we have? 4 into minus x. Minus x into minus x. So that gives us 24. Then minus 4x. Then this minus 6x, then negative and negative. Hope you keep those signs at play. That will be positive. Positive what?
X squared.
X squared. That's wonderful. Then these are like terms. What do you get?
Negative 10x.
Negative 10x plus x squared. Oh, that's wonderful. Oh, now we are growing into depth, into depth. I hope you've captured these things.
Yes.
So, okay, we can multiply ourselves again into very many things here. 6a minus b into 4a plus b. So that is our part C. So be ready. I'm going to expand only. Yeah, what is this?
6a into 4a plus b.
4a plus b
Minus b.
minus b 4a plus b. So this gives us
24a
24
squared.
a squared. That's wonderful.
Plus
6ab. Clear?
Yes.
Then this minus 4, order must follow ab, not ba. That clear?
Yes.
See? So negative with a positive, negative times positive, negative b squared. So what are those like terms? I hope they are here. Not so?
Yes.
That's 24 squared, 6 minus 4, 2ab minus 40. That's exactly. Plus 4 into 6 minus 2x. Now we want to discuss that, then that one we'll call in how am I going to handle this?
2x into 6
It will be 2x into 6 minus 2x.
minus,
Each term minus this,
yes, minus x squared into 6 minus 2x
2x plus 4,
into 6 minus
2x. That's wonderful. So that's what? 2 times 6,
12x
12x. Then 2 times 2, 4
X squared.
squared. Clear?
Yes.
So that will be
6
6x squared. The negative times the negative,
positive.
positive 2. How many x's now? This x squared and x again.
X cubed.
X cubed. Wonderful. Plus 24
Minus
8x. So like a terms, I have this and
X minus
12x minus 8. It goes with its sign, not so?
yes.
So there is this and this, 4x squared minus that, then plus 2x cubed plus 24. So what is this? 12 minus 8, 4x, then negative 4 minus 6,
Negative 10x squared.
yeah, you just have to accumulate 4 negatives and more 6 what? Then you count all of them, there will be 10. So yeah, that one now would mean you have that, then plus this has no like terms, plus 24. I think that's the final. Okay, let me put there the last. Maybe somebody has a suggestion to guide us through, which is 4p minus q squared. Let's have it 3q squared. And then a guidance to handle that.
Let me try.
You want to try? See? Try it. Let her try.
I'm just trying, I'm not sure.
Do so.
Since there is a square up, I'll just introduce the method of 2 squares.
Since there is a square up.
Yes, I'll introduce a method of 2 squares.
Somebody's asking why is it plus?
Here, when you're dealing with the method of 2 squares, you can take an example, a minus b squared. I can say, since it is a square, I can say a minus b. Also this side you put a plus b. It can become first any.
Precious, why is your face turning into a different shape?
But why is it that you don't put a negative and you put plus? Here, yes. That's the law of 2 squares. Just the law.
That's the law of 2 squares.
Then also this one plus 3.
Grace, what's your problem?
I have to know what you from not getting.
Hey, she will explain in depth, not so. Somebody has a different view also. As she presents, she also presents.
Here we shall get of QP. No. QP minus 9q squared. P squared minus and okay. That's what
yes, I see another hand. Thank you very much, Mira.
I'm just inquiring.
Yes.
There wasn't she supposed to be putting 4p into 4p plus 3q according to what she wrote up, but she interchanged it from the second step.
Here.
Yeah.
She would again have said 4p plus.
Yes.
According to her brackets.
Yeah.
Yeah, she would have said so, and this would have been what? What other error from our steps here? You see that error?
Yeah.
Yeah. But anyway, leaving her work aside, what's the meaning of to be squared?
to be 2.
To be 2.
Yeah, 4p squared minus 3p squared.
It means she had to write 2 brackets of the same kind.
Yes.
See, 2 brackets. Why were you keeping quiet? Why?
Shall we go with
You were thinking otherwise. Okay, but this, you agree with this, mathematically speaking? So, we say 4p into 4p minus 3q minus 3q into 4p minus 3q, not so? So that gives us
16p squared.
16p squared, then
Minus 12pq.
12pq
Minus 12pq. Plus 9q squared.
q squared. That's exactly. So 16p squared, then this and that will give us
Negative 24.
24 pq
Plus
9q squared. That's wonderful. We are still in expansion. I think we agree fully that is it, not so? Do we agree 100%?
yes.
See, now we have something here called identities in expansion. So, identities in expansion. What is identity? That word, your identity means what? My identity, a general identity is just, how should we call it? If they say what is your identity, you might say I'm a Ugandan, not so? So an identity is a general observation on you, a general observation. But this one, we are saying that there are some expansions which have a general expression. General expressions, we are calling them identities. So identities are general expressions that do not change. The first identity here is an expansion in the added brackets. Could you develop for me the answer for that? That won't change. See.
A plus B, A plus B.
That is, if you expand around, it will yield what? Let me see people capturing it in a group there. Could you discuss it two and you give me the answer? You said it's A plus B, fine, but what's the final? Then the other one is A minus B squared.
A squared plus 2ab plus B squared.
It is
A squared
plus
2ab
plus B squared. What of now this?
A squared minus
A squared minus. Are you guessing?
no. Yes. They don't have. What now? Let me see.
Are you there? I want that answer developed.
A squared
A squared
minus AB
minus AB
plus B squared. Yes.
plus B squared. It's like that?
Teacher, no. Teacher, no. You have got 2 minus 2 AB.
To AB.
Yes.
Yes.
That's it.
Okay. Now we go to examples. If a plus b squared is equal to a squared plus 2ab plus b squared, use the identity to find the to work out the answer of a 2a plus 3b squared. If this is that, what is the answer to this? Let's see somebody who is thinking. If I wanted you to generate an answer from this, what would be this answer? As I've seen a hand.
Teacher, for many things, you have to first multiply the first one, then you
What do you mean? What do you mean?
You multiply the first one.
Like say, what would you multiply this?
Multiply 2a
times
maybe, let's multiply it by itself.
Itself. That's what it means here.
Yes.
That it means 2a squared.
Yes. Then
plus
another one will be, I think it will have to have a b, as if you're.
That means, what will I do? Now I'll keep a 2, then multiply this term multiplied with that. 2a times
3b.
Then I add it. That
B
means
squared. Yes.
That's we are in algebra. The head should not melt.
I'm confused. Pardon me, that explains.
The identity is a general formula that will not change. It gives answers to similar things. So a plus b squared means first term you square it, which is this squared. Then you multiply the two terms with the 2, which is this times this and that. Then you add the last term squared, which is this squared. You are just applying the identity. So this will be 2a times 2a plus, now this is what? 6 times 2.
Oh, 12ab.
Okay, let me maintain that. 2 into 6ab plus 3b times 3b. So that generates us 4a squared plus 12ab
plus 9b
squared. Of course, if you opened this twice, you'll get the same answer if you didn't pass by the identity. But if I fix you that you use this, then you must be able to think this way. Now, I want to look at what we call perfect what. Okay, first develop for me this answer first. If a minus b squared gives us a squared minus 2ab plus b squared, it's number 1. Use the expression to give the answer to this, answer to p minus 3 squared. Who would do it mentally without steps? You can read the answer mentally without computing.
P squared.
It would be p squared
minus 2 into p times 3ab, then plus 3 squared,
which is 9.
yes.
So I'll definitely have minus 6p plus 9. Or somebody would discuss it mentally and say it means first term squared p squared minus 2 both of them. That's 2 times p, 2p times 3, 6, plus the last sum squared. So now, whenever you square something, the answer you get is called a perfect square. Now we are looking at perfect squares in expansion. So I think we are digging into depth. See, that means I can give you this and say right back at this at the original non-expanded form, and that's what we are going to see. So if I say write this back into this, of course what is the easiest way to do? If you are to compute this back, so you don't look at this and that. That means simply remove the square here, get the square root. This sign will tell you that there was minus. If there was addition, it would have a addition here. So you simply know p minus the square root. This is the square root of this. Remove a square, remove, or take square root here, take square root there. So you'll have p minus 3. So I hope you, can you not see it from here? Yes. Square root of 4? 2. Is 2. Remove a square? A. Then square root of 9? 3. Remove a square? B. Oh, that means I can give you right back. Now you keep those things at your attention because they are going to be called, to write back is what we call to factorize. See? So when we reach factorization, I will call in these things and say, what you factorize this, it would mean write it back as it was. See? Of course, we shall discuss the meaning of factorization in details, but I want this at your attention. So perfect squares in expansion, we will say the perfect square is just a term obtained as a result of another term being squared. See, perfect squares. So, e.g., 4 is a perfect square of what? Of 2. See? And when you square 2, you get 4. That's exactly. So, which of the following is a perfect square? So, can have the first one here. That's a squared minus 2a plus 1. Then you have of course I will pick one here that for a squared plus 12ab and plus b squared, 9b squared, 2a squared plus 3ab plus 3 a plus 1. What do you think there is a perfect square? Let me see with the reason, Chirabo?
I think a squared for
a squared minus 2a plus 1. Is it a perfect square of who? Is a perfect square, but of what? What did you expand to get it?
and 1. A minus 1.
A minus 1. Yeah, when you expand this, you get this. This is wonderful. So you just remove this square, and here you get square root. So this will be a square root of 1 is 1. So this points you to minus because there is a minus and there is a 2, which tells you that there was this expansion identity brought in for minus. So what of the next one? Is it a perfect square or not?
Yes.
It is a perfect square?
Yes.
Of who?
2a plus 3b.
Of 2a plus 3b squared. That means a perfect square. Don't put again a square. It's a perfect square of this. So if you square this, you get it. This
Yes.
is a perfect square.
Yes.
Square root of 2, is it possible? Does it have a square root? A 2. So 2 has no square root. It can't be anything without a square root is not a perfect. See? So you can't take square root of this, but you can take this, so this can't qualify. You understand that?
Yes.
So it is not what? A perfect square. Okay, so that one has closed the expanding brackets. Good. I hope now I'll call in people to discuss the rest that I'll have paused. Maybe we can throw there one to check somebody if somebody can be able to figure out if it's a perfect square or not. Okay. So, turn out part D. So, that's 9 minus 9 minus 6y plus y squared. Does that qualify to be a perfect square or not?
It qualifies.
It's a perfect square?
Yes.
See, that's wonderful. Okay, the perfect square of what?
3 minus 1 plus 1.
Hey, people are thinking. Okay, testing them on this. 25 x squared minus 50x plus 4. Let's see. Is it a perfect square?
Yes.
Let's check. Of what?
5x minus 2.
Try. If you expanded it, does it yield this? Check it. If you try to expand it, will you get this? You'll get, of course, these parts will come from it, but will this come out by 2 into 5 and 2? It would be a perfect square if this was 20. So you must be able to think out before you conclude it. It might.
It's not.
It's not, because this 50 will not yield something there. So be keen. Okay, it's not a perfect square because 50 won't come from a product of 4 and 5 with a 2. So, building and making subject of the formula. Building the formula and making subject of the formula. I hope you recall how we built formulas in senior 1. I think of a number divided by 2. Do you recall that concept?
Yes.
So today I'll only emphasize making subject of the formula, because you recall that concept. Okay, making, that means broadly building formulas were seen in senior 1. Algebra 1 was visited in senior what? 1. Then today we are looking at making subject of the formula. What is to make the subject of the formula? Easy to solve for something. See, like if I say the solve for x, I'm as well saying make x the subject of. See, to solve for that letter is to make it the subject of the formula. Okay. So examples: make x the subject of the formula. That is 2x plus p is equal to 5y minus 1. How do you solve for x? See, how do you make x the subject of the formula? Simply you apply the normal way of solving simple equations. Is your head working so well now? How can we make x the subject of the formula? Of course, to remain with x alone is to make it the subject of the formula. So I take p this side first. So what will it be? 2x plus p
minus p, 5y minus 1
minus p. So you have 2x, this will cancel.
5y minus 1.
5y minus 1 minus p. Divide by 2. So x is equal to 5y minus 1 minus, out of 2. That you will have made x the subject of.
Excuse me.
So you are excused.
In case there is a number that can be divided by 2, can you divide or just leave it?
You leave the expression like that. If there was 4 here, 4p. No, of course 2 divides. When we say over 2, we mean 5 over 2, 1 over 2, this over 2. So each part is expressed over 2. When you try, when there is a tendency of somebody finding this, maybe 10y minus 1 minus 4p, and you say this. Because somebody will say by 2, 1, by this 5. This is what? Unless you had a multiplication. Multiplication permits cancelling through by one of them. But either addition or subtraction, it means you are, that 2 is out, each one will be out of 2. So that means if you are trying to cancel, you will have to first give each one that 2. If 2 is not a common factor in all, leave it. See? So I'm doing more numbers here. So, and I request that you are going to do some, aren't you? Yeah, you are, of course, aren't you? You are over. So yeah, this one says make y the subject of the formula. Make y the subject of the formula. That's part of the question. Make y the subject of this formula. X out of 2m, that's part A. Then part B says find the value of y given x equal to 65, b equal to 3, then n equal to 10. So it is saying we solve, when it says make y the subject, it is simply saying express y in terms of others, or it is saying solve for y. See, how do simply, you see, if you add a fraction, you have to of course kill the fractions first. Remember our algebra senior one that destroy the fraction. So we can first multiply through by 2n. Okay, we can first, yes?
I think we first subtract them.
First take b there. Wonderful. So 1 over y plus b minus b is equal to x out of 2n minus b. That's very, very good. 1 over y is equal to x out of 2n minus b out of 1. Not so? So we are going to multiply through by, of course we can first help ourselves this way, then we proceed. Somebody suggests, what should we do? Of course there are two denominators that are different, that is 2n and y. We first destroy 1. So we first multiply now through by 2n, or again by y, n can work. So by 2n first, everywhere 2n, I want first remove the 2n, so 2n, clear? Die, it has died. So here we'll have 2n out of equal to x minus 2bn. So now multiply through by y and kill the y in the denominator. Out of y is equal to x. Everything multiplies everything times y. So you'll have, what do you have there? 2n equal to, what do you have? Yes, xy minus
2b and y.
2b and y, not so. Y is appearing here, but we are solving for y. When y appears in two places, we put it out. So if we remove it from here and here, what remains here? X minus 2bn. Now I'm going to divide through by x minus 2bn, and I remain with either. That is, you have solved for y. Is your head boiling down? Now putting out a number is called to factorize it. Remove it from both and put it out is to factorize it, though we are seeing factorization in the next few minutes. But here you seem to understand what happened. Y was here and here, so put it out, you remain with x. Because of course when you open it back, it goes back. Y times this goes back, y times that goes back to this. So after this, divide through by that, then remain with y. You have made y the subject of the formula. Precious. Have you really understood this material?
Yes, teacher.
You have. See. Okay, now we want to discuss next part, part B here. It says that now you substitute in these values to get y. What should we do?
Y is equal to 2
Times 10 out of 65 minus 2 times 3 times 10. giving us 20 out of 65 minus who? 60, not so?
Yes.
So you get 20 out of 5, which is 4. Is that very, very clear? I want to do another one more. So I do like 3. Then this time I'm calling in people, so warm up. There are 4 numbers for you. Will you be ready? So Chiraba, are you okay? You are not okay. Why?
I'm okay.
You are okay. That's great. That's great. So should we discuss another one here? Yeah, we're only discussing those that are a bit deeper. So next number here, it says make P the subject. S is equal to 3x out of 2y minus P minus 1. Make P the subject, or express P in terms of others. Make P the subject. Somebody to guide us. How are we going to handle those? It's also a fraction. How shall we handle this?
We add 1 on both sides.
We add 1 so that this term is left, the P term is left alone. So S plus 1 is equal to 3x out of 2y minus P minus 1 plus 1. So S plus 1 is equal to 3x out of 2y minus P. How are we going now to deal with that?
Multiply 2y minus P.
The denominator on both sides. So 2y minus P. Now when there are 2 terms, use the concept of brackets. So 2y minus P, also 2y minus P. Then it will die here. Now here you have 2 things again. Do you recall our expansion? How do you expand 2 brackets? 2y. Of course, out of 1 remains as 1. Something out of 1 is that same thing. So it leaves us with 2y into x minus P. Pencils, are you okay?
Yes.
Then
Minus P.
into s plus 1 equal to now 3 what?
X.
3x. Clear?
Yes.
So we open. This will be 2y s plus, which one is first?
Yes.
Sy.
Yes.
So plus 2y, then this and that, minus,
P.
which one is first? S. Then this and that,
Minus P.
equal to 3x.
Yes.
Which terms have P? You make sure they are together. This is not so.
Yes.
So anything without P must be taken in the other side. Are these like terms?
No.
No, this is S, Y, this is only Y. So I'm going to take these things the other side to remain with P alone so that P is made the subject. So how do we handle that? How am I going to take 2SY this side?
By subtracting it.
By subtracting it from both sides. Plus 2y minus PS minus P equal to 3x, not so? So minus 2sy. Then still I have to remove this. 2y minus 2y minus ps minus p. 2sy minus 2y. So it dies, not so? What's left? You are left with negative ps minus p equal to 3x
minus
2sy minus 2y. Now I have to put p out. P into what remains here? This is this negative what? If this is removed and this negative s minus. Now, where there was nothing, if you remove, you remain there with, because p means 1p. You accept there is a hidden one here?
Yes.
Yeah, so whenever you have a letter, you remain with 1p. So equal to 3x minus 2sy minus 2y. Then I'll divide through by this, and I'll have arrived at p. Are you breathing perfectly after that last step? Are you breathing okay?
Yes.
Of course, I'm tempted to first give in some 2 before I continue with my 2. You are breathing well. Who is ready to take us through? Yeah, who is ready?
All of us.
All of you are ready. All of you are ready. Okay. Now me, I've done mine. I want to give you also. You try out, not so? Yeah, you try out. There are going to be 2. Before I continue with the more 2, to stop the factorizations. I mean to stop making and building the formula. You are set. You are excused very, very much.
In case, going back to that second part of
the second part, this one?
Yeah, in case maybe that s plus 1 had its own fraction and it's not 1.
Like a 2? You'd maintain a 2 down, assuming it was 2y minus p s plus 1 out of 2. That's very good to think like that. See, you're thinking in depth. So, of course, we would have reached this step, but you'd have at least multiplied through by 2. You cancel again the denominators first. You'd have introduced times 2. You don't introduce it here. Here there is no positive. There is a multiplication. When you are multiplying, multiply once. So you don't introduce it here and also the other side. You first kill it before you work.
Even if the denominator was a letter.
Was a letter, you'd multiply through by that letter. See, what you do to numbers is the same way you do to letters, because you are dealing with letters which have replaced numbers. Yeah, there is one that is warming up here, and yeah, there are two here. I want to fix them on here for people to work. Now this one says that make y the subject of the formula. That is 3x plus 2y plus 4z equal to 6y. Make y the subject of the formula, then make y the subject. Now this is number 3, then number 4. Somebody should be warming up. There are two of them. This one says make P the subject of the formula. Make P. So it is P plus 3 3q out of 2 minus 3p equal to x out of y. Who can come and disorganize that one? Make P. They say make P the subject. See, there is a lot of data that is required there. That means you must have come when you've loaded a lot of data, a lot of MBs. In fact, you should have a GB, 1 GB. See who is coming, who has loaded enough data. Then come for this first. Come and take on this first. See.
Okay, they are asking us to make y the subject of the formula, and here we have 3x plus 2y plus 4z is equal to 6y. So, meaning we shall have to carry this 2y to bring it this side. So it shall be 3x plus 2y minus 2y plus 4z is equal to 6y minus 2y. So that we shall remain here with 3x plus 4z is equal to 4y. This is the same as 4y is equal to 3x plus 4z. Sorry. So you divide both sides by 4 to make y the subject. Sorry. So y is equal to 3x plus 4z out of 4.
Yeah, thank you, Chiraba. That's very, very great work. Wonderful. was enough data to handle number 4? Yes, I've seen two people. Come on guys. There is no data?
I'm going to do the first one.
Which one? This one here. You have enough data. You have used some data here.
Maybe I'm going to end where I ended.
To end where you end.
Start from there.
Then another one will start from. She will end where the data gets what? That's being courageous. That's good. So remove the mask as you explain.
I'm going to get this down figure here. X minus 3p. I'll multiply it on both sides. I'll cancel it since this one is the same as this one. X. So we shall remain with p plus 3q, which is equals to x over y, x cube minus 3p. I'll multiply also this y on both sides.
Use brackets whenever they see two terms.
X minus 3.
Ruth, what's happening, Ruth?
I'll put x on both sides, see? Here it will be py plus 3qy, which is equals x. Y on this side will cancel since also we have a y here. So I remain with 3x cube minus 3p. That's where I end.
Okay, thank you very much for being courageous. Thank you. Yeah, you want to take on from there? Shirabo? Or somebody else is willing? Okay, take over and do that. Yes, Shirabo? Okay, correct and finish even.
Okay, according to me, I'm not going to first wrap her things, so I'm going to write this side. We have p plus 3q out of q minus 3p is equal to x out of y. So we shall have to first multiply, since there is nothing to carry the other side, or maybe addition or subtraction. So we shall have p plus 3q out of q minus 3p times q minus 3p is equal to x out of y. So since we are introducing multiplication, we shall introduce the brackets as well. So this and this will be cancelled. We shall remain with p plus 3q is equal to x out of y So since this one has y, we shall multiply both sides by y. So this y and this y will. So here we shall have y into p plus 3q is equal to x into q minus 3p. So when we reach this step, we shall have to start multiplying y times p plus y times 3q is equal to x times q minus x times 3p. So here we shall have py plus 3qy is equal to qx minus 3px. So since they are telling us to make p the subject, so we shall have to remain this side with p. So it will be py plus 3qy minus 3qy is equal to qx minus 3px minus 3qy. So we shall have py, so this will be cancelled, is equal to qx minus 3px minus, so since we are going to change this 3px, since it contains the p and we are making the p the subject, so we shall have to carry this 3px this side, so we shall add it plus 3px minus 3qy this side plus 3px. So we shall be having 3px plus py is equal to qx. This will be cancelled. We shall remain with minus 3qy. So since we are removing this p and this p, we shall have p into 3x plus y is equal to,
could you carry it up?
okay, qx minus 3qy. So here we have p into 3x plus y is equal to qx minus 3qy. So since we are making p the subject, we shall divide both sides by 3x plus y. So p is equal to qx plus 3qy out of 3x plus y.
Yeah, thank you, Cherabo. You are very, very stupendous. Now we want, this is too much, this is a lot of brain work. If the brain is not really having enough data, it will not work, it cannot work up that level. This is consistency in the heat. So, but I wanted to also say, since there was no other things added here, does direct cross multiplication also solve these many steps up to here? Now, if you had cross multiply direct, you would jump up to where? You jump just here. You'd avoid these two. No, sir? You would have cut off these two. So, because you'd be having y into this, then x into this. Because of course, when there is nothing added, if something is directly one term, one block term, simply crossing. Okay, now I'm dealing with the squares and square roots. There are terms that have squares and square roots. And square roots. See. Okay, now I hope more participants will come in, not so? Yes, I've had 2 of them. Some 2 here have not participated. Called Ruth and who? And who? And Nantali. Okay. Okay, now how do we say, let's examine this. If x squared is 9, what is x? The square root of 9, not so?
Yes.
So that would give us what? 3. But we must notice that at senior 2 level now we are going to master that the square root has 2 answers. That means we are bringing that concept. That means x is 3 or x is 3 and x is what? Negative 3. Mark that. See? Now, if x, how can we build back at the square if x is equal to square root of 81? How do I remove this square root? A square root is removed by powering 2, not so? By squaring it. So you mark that the square root dies with the square root. Clear? Now, I think you've checked that in your head. To remove a square, you take a square root. To remove a square root, you square both. Yeah, now, I hope I'm going to receive more participants here. If n is equal to x square root, 2 out of m squared minus 1 express m in terms of x and n. That very right. Now it is saying, when they say express m in terms of this, they mean make m desa. Now, see, I'm doing 2. You need to listen attentively. The first item, our m is within the square root, so I have to remove the square root. But there is also a neighbor here first. First, destroy this neighbor by dividing it on both, since there is a multiplication here. So I'll divide by x, divide by what? X. So x dies there. I have n out of x is equal to the square root of 2 out of 4 m what? Squared. So square both sides. To remove the square root here, square both sides. So what will you have? N out of x squared, not so? The square root of 2 out of 4m squared minus that one squared. So this will die with that. Not so? What do you have? Now this square is for both. So it will make n to be squared and also x to be squared. That was our indices. So you'll have it as 2 out of 4m squared. Now what I'll do is to cross multiply first. So somebody guide me, what will I have after cross multiplying? N squared into 4m squared minus equal to 2x what? So open here, you have 4n squared m squared. M is first, then n squared, then minus
n squared.
N squared equal to 2x squared. So since we are making m the subject, so first take this one the other side. So what will you have? 4m squared n squared minus n squared plus n squared is 2x squared plus n what? Squared. So what will you have there? 4m squared n squared is equal to 2x squared plus n squared. What are you making the subject? So first divide through. Are you together? So this and that will cancel. M squared is equal to 2x squared plus n squared out of 4. How do I remove this square to remain with m? Take square roots on both what? Sides. Out of 4 that. So this will cancel. M alone will equal to 2x squared plus n squared out of 4n what? Squared. Chirabo, is your head still working? Remember that we are still making the subject of the formula. We are about to go to factorizations. See. Nantal, are you fine? Yeah, I want to discuss one more, then we're requesting 2 people to discuss too, then we can close down that part. So, okay. We proceed. See, we can proceed on to. How many are still working on their heads and the head is still very normal? Make C the subject, that's number 2. Make C the subject of the formula. That's A is equal to C plus square root, that's not C. That's B plus A squared plus C squared. Oh, somebody who can guide us there? What's the first step?
Subtract.
You subtract. Why not divide?
Because there is no multiplication.
Say it again.
Because there is no multiplication.
See, that's being very, very accurate. See, so we subtract b on both sides. So I will have a minus b, b minus b plus square root of a squared plus c squared. Isn't it?
Yes.
It is. So it dies. A minus b is equal to square root of a squared plus c squared. We square both sides, so I will say squared is equal to square root of a squared plus c squared squared, not so? So what do we have? Like that, equal to a squared plus c what?
C squared.
Next step,
A squared minus b squared.
a squared minus b squared. I want this, so I subtract this on both sides. Minus a squared minus a squared plus c squared. So this will die. So a squared minus a squared is equal to c squared. Again, how do I get c? How do I get c?
You make it, you introduce the square.
The square root on both sides. So you receive it as this.
Teacher.
Yes? Chinabo, you have a question?
Teacher, if you expand that a minus b squared
Oh,
and you have a squared minus a squared.
cancelling. Do you have already seen a squared?
Yes.
How many have that identity in the head? This identity, do you recall it in the head?
Yes.
What was it?
A squared minus ab
Are you sure?
plus b squared.
You recall it that way? If you expand this, that was the identity of course. But you would expand it twice, of course. The bracket would be multiplied by itself, not so? Then minus that. So break down this. Now you see the use of the identity is to put it in the, it's like a formula. An identity is a general expression like a formula, so it means put it in the what? Can't you Mira, you said can't you do what?
Cancel that is squared with the other is kept squared. Then you remain with 2ab.
See, does it mean the same? No, you cancel. Of course, we have not expanded this. So if you expand it down, you know what you'll arrive at? I will not put that expansion in there. This one is this, not so? You already know how to expand that. So you do cancel this with that and you remain with. What is the proper way of writing this? What is the proper way? Why is it this?
It's the same.
It's the same. See, it's the same. Okay, thank
So
you.
can you leave it at that stage of C because that
This one here, you can be marked depending on the marking guide, but it's better you reach there.
What if I just leave negative 2ab?
It is correct. Yeah, I want to give you more 2 here. Are you ready? Okay. I want to give you 2. Chirabo, is your head still functioning properly? Or it needs to load MBs?
I think so.
You need MBs, eh? I want to give you, how many are already take us through? 2 of them here. Ruth, are you coming this time? Because you have not been very instrumental. You have not been very instrumental. This is make B the subject of the formula. T is equal to A, that's 10 plus square root of A minus B squared. Who is coming in for that? Express K, S and D. S is the square root of KD into L minus D. Precious, I want to give you this blessing. Ruth.
We shall have to subtract 10 on both sides. So T minus 10 is equals to 10 plus minus 10. Minus 10 m minus b squared. So T minus 10 will be equals to, this will get cancelled. So we shall remain with a minus b squared, but the most thing we need is b. We have to make it the subject of the formula. So we shall first square both of them, and this is t minus 10 squared, and this and this are cancelled, so it will be a minus b squared. So here this means t, we shall first leave it at this step this time. T minus 10 squared Oh God. We shall so t into brackets t minus 10 minus 10 into brackets t minus 10 equals to a minus b squared. So t times t, which is t squared
minus 10t
minus 10t minus 10t plus 100 equals a minus b squared. So t squared, let me see, 10t minus 10t, this will get cancelled.
no
Oh,
20t negative 20t
minus 10t, so it will be negative 20t plus 100 equals to a minus b squared. So this
we add both sides. I mean subtract both sides.
so we shall have to subtract a on both sides. So t squared minus 20t plus 100 minus a equals to a minus b squared. So these will get cancelled because the thing we need is this side. B should be the side alone because it's the one we need to make the subject of the formula. So t squared minus 20t plus 100 minus a equals to negative b squared. So we shall we put a square
No, you introduce square roots.
so
On both sides.
so t minus 20 t plus 100 minus a equals to negative b, and they asked us for b and non-negative b,
We divide both sides.
so shall divide both sides by negative 1. So t here the negative and negative will disappear, then t minus 20 t But can't this plus 100 minus a equals to b. Here is out of -1.
You have a suggestion? Yeah, you can suggest. I think this one will be for yours. You'll do it where you are seated alone, plus the exercise I will give you. See, now, what were you asking?
Okay, I don't know that all our kids are right, but there were they introducing the square root.
Yes.
She didn't have to cancel that.
She didn't have to cancel here.
Yes.
Because it can't cancel unless there was a 2 everywhere.
Okay.
See, okay, that means we maintain our square root here.
Yes.
But another method I wanted to ask you, can you find the square root of -1 and you get it on the calc?
I think no.
There are no negative square roots, so you can't take the square root when there is still a what? A negative. You have to first divide through by a negative. So, Ruth, are you okay? B squared, so divide by -1. Every time we'll divide, not so? So, wherever you introduce a negative, positive over negative? Negative. Negative over negative? Positive. Positive, negative? Positive, negative, negative?
Positive.
Equal to be what? Squared. So you now introduce a square root. I hope you will not say that, sir, you can't introduce it here because there is a negative. No. These are letters. Of course, other parts have positives. So you don't have their values to know whether the final result will be a negative or a positive. These are many things. This is a positive term. So they can have bigger values than negative. So you don't know. So I hope somebody understands my argument.
Yes.
Yeah. Unless you add only negativity, you can't take its square root. So I hope that's it, class. And we are discussing factorization shortly.
Can't I just leave that B on this page?
Can't you just leave that B?
Just like that.
This is not correct, of course. She lost track from here.
She was asking in case the answer was correct.
Was B?
And I leave B this end on the right hand side.
I've not picked her.
Teacher, it might be according to your answer there, the second last step.
Oh, you leave it this way. See, it is correct. But then why would you want to make work not look beautiful and attractive? See, would you like to look ugly in the mirror? In the mirror in the morning? See, math is beauty, therefore endeavor to present beautiful work. Now shortly we are discussing factorization, and we shall finish with solving equations later on.